So we left off talking about synchronization last time, and what I want to do is finish up that particular lesson. And what we're going to do here is we're going to take a look at how you might implement a better, more thread-safe queue, synchronized, so-called BusySynchronizedQueue, by using synchronized methods. And you'll see in a moment this will fix some of the problems we had with the non-synchronized version, which was absolutely completely incorrect, but it won't go quite far enough. In fact, it's really just a partial solution. It doesn't go and it doesn't give you a complete solution. It gives you a partial solution. So the particular example here, you can download this. I'll run it for you later. It shows how this works. And it basically is a concurrent producer-consumer app that will pass messages between two threads via a so-called busy synchronized queue. And this is modeled on the Java array bounded queue. We're going to implement the offer and poll methods. Talk a bit more about their semantics in a second. We'll see how they work. Here's it's actually not a sequence diagram, it's a class diagram that shows the design of this thing. We have an interface called bounded queue, and bounded queue has a number of methods in it. And then busy synchronized queue implements the bounded queue, and it fills these things in using synchronized methods and a linked list and some other stuff. You can download that and look at the implementation of that there. Here's a sequence diagram that shows how the unit test works. You can grab a unit test, of course, it's part of the test release. It starts out by having a main thread that's going to coordinate the other two threads in the test. The consumer and producer thread are going to generate and process the messages sent via the busy synchronized queue, respectively. And you'll see that the offer and poll methods are synchronized. And so what offer does is it tries to put something into the queue, and it'll do that in a thread-safe way, so you won't have to worry about corrupting the internal state of the queue. However, if the queue is full, then offer will return right away without doing anything. It'll return false instead of true. And likewise, poll will return null if there's nothing in the queue, in a thread-safe way, of course. And if there's something in the queue, it'll pull the item off and return that. So offer and poll don't block, but they're also thread-safe in the sense that they don't corrupt the internal state. So let's take a quick look at the implementation. You can find the implementation here, but it's easy enough to show the key points just on the slides. So busy synchronized queue is a queue, and this queue is going to have the offer and poll methods, and you can see that they're synchronized. And that means that only one of these methods can be running on a given object at a time. And we'll take a deeper look at what they do in a second. The key thing to note, though, is that only one thing can be happening. Now, this is going to solve our race condition problems that we had with the earlier implementation. However, allowing only one method at a time is actually too restrictive in some situations. And so we'll talk later about other implementations of queues. For example, there's something that's in Java called a linked blocking queue. And a linked blocking queue is a double-ended queue implemented as a linked list. And the way it's implemented internally actually allows producers and consumers to run in parallel inside the critical section. And as long as there's no contention, as long as the queue isn't empty or full, the offer and poll methods will actually run at the same time. So that would be an example where you would have a more fine-grained synchronization mechanism where multiple threads can actually be inside the methods at the same time. And then they have random locks that they use to give finer level control over accessing the internal state. Using synchronized methods doesn't give you that degree of granularity. So that could be a problem. When you add the synchronized keyword, you're going to have two things happen. One thing that's going to happen is that offer and poll on the same object can't interleave. In other words, each method call is atomic, so you don't have to worry about race conditions, accessing shared state. And the second thing you have is the so-called happens before relationship. And what that means is that when you add or remove the items from the queue, from the underlying linked list, which is not thread-safe, of course, the consequence of using synchronized is the state is automatically flushed out of the caches so that the other threads can see what happened after you inserted something. So synchronized is doing a couple of things. It's ensuring atomicity, so you don't have race conditions, and it's also ensuring visibility. So the information gets pushed out of the cache, so it's visible to other threads running on other cores. So those are the key things that are happening when you have synchronized. So let's evaluate this. There are some, obviously this solves one set of problems, but there's also some limitations. And the main limitation, and I'll show you this when we run the program, is that if the queue is empty or the queue is full, concurrent calls to these methods will busy wait. So rather than block, it'll go ahead and return right away, and it'll just sit there and spin. And when we look at the test program later, you see that that's going to be quite a problem. As a result, what you want to be able to do here is update this implementation to be a bit more sophisticated so that you don't busy wait. And the way to do that, as we'll see in a second, is to use the wait and notify mechanisms that are provided by Java built-in monitor objects. So we'll take a look at that in just a minute. All right, let me go ahead and run the program for you. All right, so here is our little program. Hopefully it'll still work. So we're going to run it for, it's like 100,000 iterations, and you can see that so far it's working. The thing to note, and we'll see this when we run the other version later, is that this takes longer to do its thing than you might expect. And the reason is because it's sitting there spinning when the queue is either empty or the queue is full. And if we take a look here, so you can see it's finished. If we take a look here at the various tasks, let's go take a look at the code here. So the way this code works is we go ahead and we'll have a main program, BusySynchronizedQueue test, and this will have a producer and a consumer. And you can see the producer is going to sit here and basically run in a separate thread because the producer implements runnable. And so it's going to run in this thread, and it's going to iterate for however many times we told it to run. It's 100,000 times. And it's going to call offer. And you can see if offer returns true, that meant that it actually put something in the queue, so the queue wasn't full. And so it increments the count and so on. But if it returns false, that means it tried to put something on the queue, but the queue is full, so it just had to keep spinning. So offer will spin when there's a full queue. And then down here we have the consumer, and the consumer basically does a similar thing. It sits there and it first tries to get the initial item off the queue, which may spin for a while because the things may start up at different times, so there may not be anything in the queue at first. And once we're actually in the main loop, we're going to call poll, and if there's nothing in the queue, poll will return null. So if it returns null, we're going to increment the null count, which indicates how many times there's nothing there. And only if there's something there, then will we go ahead and do the various operations. So as you'll see, we come down here, we create a producer and a consumer thread, we start them running, and then we wait for them to finish. And let's go ahead and run this test. This test that I'm showing you here is actually the JUnit test. Let's see if we can run that. Hopefully that'll work. There we go. Okay. So you can see here, it might be a little bit hard to see. I'll read it to you. So we ran this thing for 100,000 times, and you can see here that there was basically 27,346 null returns. So what that means is that, quite a bit of the time, it was about a third of the time when it went to pull something off the queue, there was nothing there, and so it would just spin. And so that's why the performance of this is a little bit slower than we might want. And you'll see that when we look at the implementation that does it correctly. So this is illustrating how you can use something that's synchronized, so your program is not incorrect in the sense that it doesn't have race conditions. However, the consequence is that its performance is poor and you're just spinning and wasting cycles. All right.